Hi there, welcome to edupediaworld.com. You're watching the videos on surface area and volumes. Now in this video we'll discuss basic concepts of surface area of cube and cuboid, so which are very important from the exam point of view, since most of the questions will be mostly based on surface area of cube and cuboid. However, there are some complex figures in which one or two part can be cube or cuboid, so that's why it's very important part of this chapter to know how we can find the surface area of cube and cuboid. So let's get started. First we'll discuss what is cube now. So let's first discuss what is cube. So cube is a 3D shape. It's a 3D shape, or we can say it's a solid figure, right, which has base as square, right. This means that cube is derived from square in which all sides are equal. All sides are equal, right? So we can say that 3D shape, it's a 3D shape and or a solid regular figure in which all the sides are equal, all the three sides are equal. So in this figure we have defined, let's say this side be A, this side be A, and this side be A. So let's say this is length, this is breadth and height. So in cube, length, breadth and height are equal, and we have assumed in this part of the video let it be A. Now when we open the cube we get a structure like this, as you can see. So we have 6 parts, 1 2 3 4 5 and 6, right? So what we need to do is we need to derive the formula for surface area of cube. So what we can do is we can calculate the area of each part 1 2 3 4 5 6 separately, and then we can add them to get the formula of surface area of a cube. So let's see how we can do this now. So we can say that area of square 1. Now why we are saying it square 1? Because it has a base as a square. This means that all the parts of a cube should be square. So this means all the 6 parts of the cube should be square. So we can say that area of square 1 will be A times A, so which is A square. Similarly we can say that area of square 2 will be A times A, so which is A square. Same, area of square 3 will be equals to A times A, which is A square. Similarly we can say that area of square 4 will be equals to A times A, so which will be A square. Same way we can say that area of square 5 will be A times A, so which is A square, and area of square 6 will be equals to A times A, so which is A square. Now we have the 6 parts, so what we need to do is we need to add all these 6 parts. So we can say that now surface area of Q will be equals to A square plus 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 A square. So we have 6 parts, 1 2 3 4 5 and 6. So we can say that then surface area of cube is equals to 6A square. So this is how we can derive the formula of surface area of cube. Now why we need to derive the formulas of areas of surface area of cube and cuboid? So let's say we discuss example like this. Let's say we have a box like this, right? So let's say we have a box like this, and the question comes, we need to paint this box without rooftop, right? So we need not to paint this rooftop, right? So this means we need to paint only 5 parts out of 6. So if you know the concept how the formula has been derived, so then you can solve this question easily, right? So that's why we are deriving the formulas for area of cube and cuboid. So now let's discuss cuboid now. So cuboid, first of all, it has a rectangular base, means it has different length, breadth and height. Means it has a different length, breadth and height. So we can say that cuboid is derived from rectangle, right? So when we open the cuboid, so we get a structure like this, same structure but of a different length, breadth and height. So let's see how we can derive the formula for the surface area of a cuboid. Now we have marked over here in this figure as 1, 2, 3, 4, 5, 6 parts. So let's say how we can derive the formula now. So first of all we can write area of rectangle 1 will be equals to length into height, or it can be written as LH, right? Then we can write area of rectangle 2. So let's say we have a 2 over here, so we can write area of rectangle 2 as L into B, so it will be LB, right? Then we can write area of rectangle 3 as L into H, so which is LH. Then we can write area of rectangle 4 as L into B, so which is LB. Then we can write area of rectangle 5 as B into H, so it can be written as BH. Same way we can write area of rectangle 6 as we can write B into H, so which is BH. Now what we need to do is we need to add all the 6 parts to get the surface area of a cuboid. So we can write surface area of cuboid can be written as LH plus LB plus LH plus LB plus BH plus BH. So we have 2LH, so we can write it as 2LH plus we have 2LB, so we can write 2LB plus, so we have 2BH, so we can write 2BH. Now we can take 2 as common out, so it can comes out to be LH plus LB plus BH. So we have a formula for surface area of cuboid as 2 times LB plus BH plus HL. So this is how we can derive the formulas for cube and cuboid. Now let's discuss some of the examples related to cube and cuboid, how we can use this concept to solve various type of questions. So let's discuss the example 1. Now the example 1 says that Mary wants to decorate her Christmas tree. She wants to place the tree on a wooden box covered with colored paper with picture of Santa Claus on it. Now she must know the exact quantity of paper to buy for this purpose. If the box has length, breadth and height as 80 cm, 40 cm and 20 cm, so we need to find how many square sheets of paper of side 40 cm she will be requiring. Now so let's say how we can solve this question. So first of all what we need to do is we need to find the surface area of this box, and then we need to divide the surface area by the area of square sheet to get the number of sheets. So let's see how we can solve this question. First of all, it's given that length is 80 centimeter, breadth is 40 centimeter and height is 20 centimeter. So since we need to cover the full box, so we can apply the formula directly over here. So we can say that surface area of cuboid will be equals to 2 times LB plus BH plus LH, right? Or we can say that surface area of box will be equals to 2 times LB means 80 times 40 plus BH 40 times 20 plus LH 80 times 20, right? So it will come out to be 2 times 3200 plus 40 times 20 which is 800 plus 80 times 20 which is 1600, right? So what we need to do is we need to add all the three parts. So it will be 3200 plus 800 plus 1600. So it will come out to be 0 0 10 16 and 5600. So this will be equals to 2 times 5600. So it will come out to be 11,200 centimeter square. So we have a surface area of the box. Now what we need to do is we need to find the area of a square sheet. So first of all, it's given that side of square sheet is 40 centimeter. So area of square sheet will be 40 times 40, so which is 1600 centimeter square, right? So what's the next step? We need to find the number of sheets required. So we can write number of sheets required will be equals to, we can say, surface area of box divided by area of sheet, right? So this will come out to be 11,200 divided by 1600. So when we divide this, it will come out to be 7. So we can say that number of square sheets required will be 7. So this is how we can solve these type of question. Now let's discuss the next question, next example, example number 2. Now so it's very interesting example, so you have to watch this part of a video very carefully. Now the example says that Hamid has built a cubical water tank with a lid of for this house. Each has an outer edge as 1.5 meter long, means this is 1.5, this is 1.5 meter long. Now he gets the outer surface of a tank excluding the base. You have to remember the base is excluded, so this means that we cannot use the formula directly over here. So that's the use of knowing the concepts. Now we need to cover with the square tiles of side 25 centimeter each. So we need to find how much he would spend for the tiles. If the cost of the tiles is 360 per dozen, so let's see how we can solve this question now. So it's given that, or we can say that edge of a cubical tank is 1.5 meter long, or it is 150 centimeter, right? So excluding the base, so this means we need a 5 parts out of a 6 parts of a cube. So we can say that surface area of cubical tank will be 5 times 150 times 150. So how this is coming? Let's say we can say that surface area of cube is 6a square. Now over here we need not to cover the base, so we need to exclude one part. Let's say minus a square. So what we will get? We'll get 5a square. So that's what we are doing. Surface area of a cubical tank is 5 times a square, so which is 150 times 150, right? Now what's the next step? We need to find the area of a square tiles. So it's given first of all the side of square tile is 25 centimeter. So this means we can write area of square tile will be 25 times 25 centimeter square, right? Now what's the next step? Next step is we need to find how much tiles required. So we can say that number of square tiles required will be 5 times 150 times 150 upon 25 times 25. So let's say 5 times of 5, 1 3, then 5, then 6, then 5, then 30. So it will come out to be 6 times 30, so which is 180 tiles. Now it's given that its cost per dozen is 360, right? So this means cost per tile, right, it will be 360 by 12. so it will be 30 rupees. So now let's discuss the example number 2 for this video. The example says that Hamid has built a water cubical tank with a lid for house, each with outer edge 1.5 meter long. So this means this is 1.5, this is 1.5 meter long. Now he gets the outer surface of the tank excluding the base. So we need to note that the base is excluded. So this means we need to cover only the 5 parts out of 6. So this is the use of concepts. If you know the concepts, you can solve this question now. However, you cannot apply the formula directly over here. So we need to know the concepts very well now. So we need to cover with the square tiles of side 25 centimeter. Now how much he would spend for the tiles if the cost of the tiles is 360 per dozen. So let's say how we can solve this type of question now. So it's given that edge of cube is 1.5 meter long, so or we can say that it is 150 centimeter, right? So we need to find the surface area of cubical tank, or we can say that now. So in this cubical tank only 5 parts are covered. However, the surface area of cube is always 6a square. However, here we are covering only 5 parts. We need to take away 1 part, so which will be left with 5a square. So we can write that surface area of a cubical tank will be 5a square. Now we have a 150 as a side, so we can write it as 5 into 150 into 150 centimeter square, right? Now next is side of square tile is given 25 centimeter, right? So we can say that area of square tile will be 25 times 25 centimeter square, right? So we can say that now the number of square tiles required will be, it will be surface area of cubical tank divided by area of square tile, right? So this will come out to be 5 into 150 times 150 divided by 25 times 25. So it will be 5 times of 5, 5, 30, 5, 6, 5, 5, 30. So we have 180 tiles. Now the cost of dozen tiles is 360. So this means cost of one tile will be 360 divided by 12, so which is 30. Now the cost of one tile is 30. Now so we can say that total cost will be 180 times 30. So if we calculate this, it will come out to be 5400, or we can say that it will be rupees 5400. So this is how we can use the concepts of cube and cuboid and concepts of 2D shapes to find the various type of questions. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day ahead.